Hello friends, welcome to Electrical Engineering Convention. This is a channel for discussing about the concepts of electrical engineering and electronics engineering. So the first concept that we are going to see today is the phase lock loops. PLL is a very common circuit which is used in many of the electrical and electronic circuitry. So let's get into it. So what is a PLL? A PLL is a control system that generates output signal based on the phase of the input signal. So basically what it is it is a control system. Basically it controls something. So what that is, when you give two input signals and if the two input signals have a difference of phase, it generates a corresponding output signal. So that's the basic function of the PLL. So because of this, it finds its application in demodulators, clock generation, clock recovery, and frequency synthesizer, and many more. Usually in this playlist, which the other videos that we are going to follow in this series, we will be seeing PLL used as a frequency synthesizer in mostly the TX and RX, which is the transmitter and the receiver blocks of a radio frequency system. So where the frequency synthesizer is useful is wherever we need a signal oscillator for the carrier. So wherever we need that, we'll be using a PLL. We'll see about that in detail in the next videos, but this one is about PLL. So now, this is the basic block diagram of a PLL. So we have two inputs for the PLL. We have two inputs for the PLL, input 1 and input 2. Both of the inputs go into the phase detector, and the output of the phase detector is given to the loop filter, and the output of the loop filter, the signals are filtered and given to the VCO. The VCO's output is partially taken as the output of the PLL, and it is also negatively feedbacked. So we are calling it negative feedback because we are getting it from the output and giving it to the input. So we are taking the output of the VCO and feeding it to another block which is called as divide by n, which is a frequency division block, and we are dividing the frequency by a factor of n, and then we are giving it as an input to the phase detector. So this is the basic block diagram. Now let's see what each block does in detail. So now let's get on to the phase detector. Sorry for that. Yeah. So the phase detector. What the phase detector does is it gets two input signals and compares the phase difference. So it is very simple. So let's say you have two signals which are flowing from 0 to 100 and 100 degree to 0 and so on. So what it does is it compares that signal with another set of signals, and after comparing, what it does is it generates an output voltage that is proportional to the difference of the input. So the output of the phase detector is called as the tune voltage. This tune voltage goes as the input to the filter, as how you saw in the block diagram. So whenever it compares the two input signals, the two signals should be different in order to produce a tune voltage. If the two signals are the same, which means the phase detector's output is 0, which is it compares them and it says that there is no difference. This condition is what we call it as locked condition. We call it PLL locked. This phase detector circuit can be simply realized by using an XOR gate. So let's say we give two inputs A and B to the XOR and we get an output C. So this is the truth table of the XOR. So you have two zeros, which means that the two inputs are same, and the XOR gives you a 0, which means it is low or no output. When the two inputs are the same, that is 1 and 1, which means that the output is 0 again. But if you have 0 and 1 and a 1 and a 0, you get a output 1, which means that you are getting some signal. So let's look at it graphically in order to understand it better. So if you see this, you have two input signals, input signal 1 and input signal 2, and it goes across the time, and I have just segregated the time slots based upon these dots. So let's assume that this is time slot A, B, C, D and E for both the two signals. So let's say at time slot A, the input signal is 0, it is low, and at time slot B, it is again 0. Now let's come to the input signal 2. So at time slot A, the input signal is 0, and at time slot B, the input signal is 1. So now what the phase detector does is, it compares the input signal 1 with the input signal 2, and it says 0 and 0, so don't show anything, which is no output, and it is 0 and 1, which means that you have an output. So you see a waveform. You can very easily realize this on a basic PLL circuit with the basic breadboard and two SIG gens and an oscilloscope or a signal analyzer. And whenever there is a difference in the phase, which is either it is high or low, you generate a signal that is proportional to the difference of that. So this XOR is a basic understanding for the function of the phase detector, but it is not exactly an XOR. This is just for the understanding purpose, because we are not taking into consideration the phase and the amplitude of the signal, because it compares that too. So now what we do is, we generate a proportional output, right? So we called this output the tune voltage. We called it the tune. The tune voltage is given as an input to the filter, and it is filtered by this loop filter. The reason why it is called as loop filter is, it runs the negative feedback loop that we already saw in the block diagram. So the loop filter drives it, and it gives the tune voltage as an input to the VCO. The function of the VCO here is interesting. So whenever you have a small tune voltage, it generates a corresponding frequency output. So this is a basic understanding graph. So I am just plotting X versus Y, and this straight line here is the tune voltage. So whenever you have a low voltage here, it generates a corresponding low frequency, and whenever you have a higher voltage, it generates a quicker wave, which is a faster wave, meaning higher the frequency. So this is actually given as the input to the divide by n block. The divide by n block is a very simple block which can be realized using a D flip-flop generally. So what this divide by n block does is, it divides the frequency based upon the n degree. So let's say if you are giving an input signal of 10 megahertz to the divide by n block, and if you are dividing it by 2, we'll get a 5 megahertz output. So this 5 megahertz output is in turn fed to the phase detector. So it keeps on comparing this. So let's assume that we are having a 5 megahertz signal as the input, and the VCO generates a 10 megahertz, and we use a divide by 2 block, and the output of the divide by 2 block is 5 megahertz. So on the second instance, if you compare, the input signal 1 is 5 megahertz and the input signal 2 is again 5 megahertz. So when both the inputs are 1 or the same, which means that the output is 0, which means that we are not generating any tune voltage. So this condition is called as the PLL locked condition. So this is the basics of the PLL, friends. If you have any questions, please post it on the comments, and we'll be doing the RF transmitter and receiver blocks in the future, and we'll be going on with some of the other block diagrams which are very useful, and it is good to refresh the basics on these things. So thanks for watching, and if you need any other topic specifically, please put it on the comments, and if you like the video, please share it, like it and comment it. Thank you, and please subscribe to Electrical Engineering Conventions. Thank you for watching.